Hello everybody, today I am going to prove a theorem that I think is very elegant and it's not that hard to prove either. It's called Menelaus Theorem. Actually, I'm not sure about the exact pronunciation here, but the theorem states basically when you have a triangle, in this case it's ABC, and you draw a line across that intersect the line segment AB with X, the line segment AC with Y, and the line extended from BC at Z, then you have basically the equation AX over XB times BZ over ZC and times CY over AY is equal to 1. So this is the statement of the theorem. There's also a reverse of the theorem that I'm not going to talk about it today. It's basically when this equation is satisfied, then the line when you assume that the x, y, z and are not on the same line, and when this expression is satisfied, then x, y, z are collinear. So that's the reverse of the theorem. So given this theorem, the statement of the theorem, I would like to pause for a while. So if you want to prove it yourself, you can pause the video right now, and later on I'm going to give you a hint. Alright, so now we're back. So look, so now I'm going to give you a hint. So if you want to give it a second try, you can do it after pausing the video after I give the hint. So looking at the expression, you will notice that there's really not much you can do about the three ratios here, because you cannot really find any equivalence from here, like AX over XB, what is it equal to? How can you transform it to some other value and to eventually make all the things multiply to 1? So a very common way to do this sort of problem is to construct similar triangles by drawing additional lines. So in this case, if you want to do it, the one way to do it will be to draw a line that passes through vertex C that is parallel to AB. Let's do it right now. Okay, so now assume this line intersect with x, y, z at point P, right? So if we assume this there's this point, then as you can see, we actually constructed a few parallel triangles in this case. And now I'm going to pause the video again, so that if you want to try to prove it, you can give it a second try. Okay, so now we're back. And so given this problem, I think it's very clear that after drawing the line, additional line here, we have a lot more similar triangles to deal with. So now let's try to prove it. The first thing that we notice is that we have triangle that these two triangles are similar. So PCZ and XBZ, because PC is parallel to AB. So so basically, because of these two lines are parallel, so PCZ is actually similar to XBZ. So let's write it down here. So PCZ, triangle PCZ is similar to triangle XBZ. So what can we do from here? We can actually construct the fact that because the corresponding sides of two similar triangles, they have the same ratio. So we know that this BZ over ZC is actually equal to XB over PC. So let's try to write it down here. BZ over ZC is equal to XB over PC here. So this is one equivalence that we can get. As you can see, BZ over ZC is appears in the original expression, so we might be able to replace this. So from the parallel line construction, we can actually see another set of similar triangles. So YCP is actually similar to YAZ because these two lines are parallel. And again, let's try to see if we can construct any equivalence here. So given these two triangles are similar, we know that CY over YA is actually equal to CP over AX, right? So let's write it down here. So we know that YCP is similar to YAX, and that gives us the equivalence of CY over YA is equal to, here in this case is PC over AX, right? So now we have constructed these two equivalents. Let's substitute it into the original expression that we want to prove here. So it goes all the way here, and let's try to prove. So AX over XB times BZ over ZC times CY over AY. Because we have proved these two equalities, let's try to substitute them. So exactly, so BZ over ZC is equal to XB over PC. So we can replace this value, replace this value with the value here. So that will be AX over XB times this value, which is XB over PC. All right, so now we also prove that CY over YA is equal to PC over AX. So we replace this with this, and that will give you PC over AX. All right, now it's a very clear that now it's equal to 1 because the AX and the AX cancel here, the PC and the PC cancel here, and the XB and XB cancel here, and it's exactly equal to 1. So QED. Yeah, we have finished our proof.